Okay, welcome back, Honors Algebra 2. This won't be as long as it looks because we're doing some of it in class together on Tuesday when you guys are back from your 4-day weekend. Big shout out to Mrs. Delzati this time. This beautiful note sheet you see in front of you was the creation of Mrs. Delzati, because you guys know that I don't usually do nice things like that. My handwritten notes are usually what you guys get. So, big shout out to her. Alright, today we're going to talk about big arc, little arc. We're actually going to talk about little arc and sine inverse today. We'll talk about big arc in class. First thing, unit circle. You guys should know that this is 0 degrees, 90 degrees, 180 degrees, and so on and so forth. And these are the coordinates. So if I graph the sine curve or the y values at that at those angles, at 0 degrees the y is 0. At pi over 2 or 90 degrees, the sine is now up to 1. Down here at 180, the y is back at 0. At 270 or 3 pi over 2, now it's negative 1. And finally, we do a complete cycle by going around the full circle. So we're back at 2 pi or 360. Okay? However, sine goes on forever because you can go around the circle a bunch of times. So how are multiple cycles on the curve generated? Generated by going around the circle multiple times. Okay? Now when you have your axes here, your x-axis is your theta, and our independent variable will be our theta or our x, and usually your dependent, your y, is dependent on your x. The x value on the graph is theta, and the y value is the sine of theta. Okay? So that's what's happening on those graphs. But we don't really care about those because we'll be dealing with those next chapter. I was just showing you what the graph looks like so we can actually look at what happens when we find the inverse. So let's look at the inverse of this. Now this is the graph of the inverse. Now this is sine of theta and this is theta. How do we find an inverse? We switch the x and the y. So now the x value is the sine of theta, or the value of sine, and the y value is now theta. So it kind of reverses. So is this graph a function? Hopefully you guys can look at that and tell me no. Because it fails, this picture fails the vertical line test. We don't use the horizontal line test on the graph itself. We use the vertical line test. So this is not a function. So there's going to be multiple values, but it's not a function. That'll come into play during class on Tuesday. We'll define big arc, which will be a function. But right now, this curve goes on forever up and down. Okay, so let's go to the next page. So let's look at this. Give two angle measures with sine of theta is 1/2. Well, that's a unit circle angle. You guys should be able to either remember, so when y is 1/2, that's barely moving up. 30 degrees is one of them, because 30 degrees sine is 1/2, cosine is √3/2. And then over here at the same reference angle, but this is an angle of 150. So 150 also has a sine of 1/2. That's just looking at the unit circle. If you want to do it graphically, remember this is sine theta. So this is like 1, this is -1, this is 0. So 1/2 would be here. And if I draw that line up and down, you get, remember this is your angle, the y-axis is now the angle. This angle is 30 degrees. This angle right here is 150 because it goes back to 0 at 180. Okay? That's just a graphical representation of this circle. Okay? You won't have to do that. Don't worry about that. I'm just showing you two different methods of how to get those. But you should be able to do this from our unit circle. Are they the only angles with the sine of 1/2? Well, if you look at this, hopefully you see that the line goes up and down forever. There are values here that have the sine of 1/2. There are values here. So no, they are not the only values. How do we find the other angles? Well, we go around the circle again, which is basically adding 360 degrees or 2 pi. Okay? Because if we go around again, we're back at those spots where it's 1/2 again. Okay? So what's the notation for finding the general values of an angle given the sine value? Okay, here are the notations that we use. The angle itself is equal to little arcsine of the input, or it can look like this, which is something where you take the inverse and find angle. That's what you did in geometry with second sine, second cosine, second tangent. Now, this is the notation to solve, but the final answers, when you find your theta, when you do arcsine of y, you get a theta, but you also get, general means we get multiple values. So we can get like 30 degrees, but we get everything else after that. So it could be arcsine of y is equal to theta plus 2 pi k or theta plus 360 k. This one is if you're in degrees, obviously. This one's in radians. So, like I said, when you find that angle, so for example, with the 30 degrees, we could have done inverse sine of 1/2 and our calculator would have given us 30 degrees. If you add 360 to that, you get 390 degrees. Sure enough, the sine of 390 degrees is 1/2 again, because it goes around the circle once. So there's multiple values, and this is how we represent it. Okay, so let's do a problem. And here's helpful hints. First answer is always found using the calculator, so you guys should have no thought process at all. And this is the type of problems you're going to see on the test and the quiz. None of the stuff we've done so far except for these general forms which you're going to have to use. So let me get my calculator ready. Okay, so it says solve for x and round to the nearest minute. First thing you got to do is you use the calculator, that's what our helpful hint is, to get the first angle. So remember, arcsine, little arcsine, is the same thing as little sine inverse. So you always use sine inverse, or use the inverse button on your calculator. Make sure you're in degree mode because I say round to the nearest minute. And then just type in, this is just like what you did in geometry actually, find the angle when sine is negative 0.452. So you hit enter, and that's the angle, however we want it to the nearest minute. So I'm going to hit second apps 4, and I get negative 26 degrees and 52 minutes because that does not round up. So let's write that down. I get theta is equal to negative 26 degrees and 52 minutes. Now, it could be also anything that is the same spot but around the circle a full time. So plus, it could be any 360 degrees times k, where k is the number of revolutions. So if you revolve it once, it would be negative 26 degrees, 52 minutes, plus 360, plus 720 if there's 2 revolutions. And that'll get you all the multiple answers. However, there's another spot on the circle where the sine is negative 0.452. So let's draw the circle. So we got our first answer just from the calculator. We're in degrees. Now I'm going to draw my circle. It's very important to show this work and draw your circle. Negative 26 degrees, 52 minutes is about right there. It's just an estimate. So this reference, so that means that this is a reference of 26 degrees, 52 minutes. That's the reference angle. I made it positive because we're going to use it on the other side. So the other place where sine is negative is quadrant 3, down here. So over here, at the same reference, this length will be negative 0.452 because this length is negative 0.452. This angle is 26 degrees 52, and the length of y is negative 0.452. That's what that's saying there. So now we have the length of y is negative 0.452 here, and that means that this angle also has to be a 26 degrees 52 minutes. So the final step now is give me the second angle starting at 0. So here's 0, and we're going here. So how do we find that full angle? Hopefully in this situation you see that you just do 180 plus the 26.52, or 26 degrees 52 minutes. So my theta is 180 plus 26 degrees 52 minutes, and you get the other angle is 206 degrees 52 minutes, and then at that position we can also go around multiple times in the circle. So I also have the plus 360 degrees times k. So the two things that are boxed are the two solutions to this problem. We got the first one just by typing it into the calculator. We got the second one by drawing where that is and making the same reference angle where sine is negative. The key is y is negative over here, and putting that reference angle in there as well, and then going around. Okay, so let's go on to cosine, and then it's very similar to sine. Cosine, again, the only thing that's different is now at 0 the value is 1. So 1, negative 1, 0. So the angle is 0, 90, 180. And again, if you do it in pi's, it'd be pi over 2, pi, 3 pi over 2. And we're back at 360. So again, a full cycle is still 360 degrees, or 2 pi. Inverse is the same thing as we did before. Now the general notation for this is the same thing, but it's cosine. So we would say that it's arc cosine of y equals theta, or you can also use cosine inverse of y equals theta. The forms for the angles themselves, arc cosine of y equals theta plus 2 pi k, or it could be theta plus 360 degrees k. Again, it's these values because it takes a full circle to go around. So this is radians, and these are in degrees. Okay, so these are the two options again. So sine, it's this, or cosine, it's the same general solutions as sine because of the cycle. The cycle is one full circle, and sine does not repeat itself. The cycle doesn't repeat itself unless you're done with going through the full circle from 0 to 360. Okay, so now this one we don't even need a calculator, although we can use the calculator if you wanted to. You can do second cosine of root 2 over 2 when you're in degree, and you should get that's 45 degrees. However, since it's root 2 over 2, you should recognize, wait, that's a unit circle angle. And I remember that x is 45 at root 2 over 2 here, and this would be 45 degrees, which is what your calculator would give you. So the first answer to this problem using the calculator is 45 degrees. But again, I just am going to do it. Plus 360 degrees k. Alright, that's only one solution though. Well, it's multiple solutions, but it's one of the spots on our circle where we get multiple solutions. There's another place where cosine is positive. We have to be careful. Cosine is also positive here, going in quadrant 4. Do not go over here because that means cosine is negative now, and that's not what we have. So the other place I have positive is here. So a reference angle of 45. So now you have to figure out, well, how big is the angle from the beginning of here all the way to there? Well, it's basically the other theta is a full 360 minus 45. So you get 315 degrees is this spot right here. Then we have to add all the revolutions we can make with it. So my final answer is 315 degrees and 360k. Again, draw the circle. It makes it a lot easier to look at. Alright, so that is cosine. It works the same as sine, except for you have to think in terms of x, positive and negative, when you're moving on and making your circle. And like I said, we're doing a bunch of these in class tomorrow, or whenever we see each other again. Alright, now tangent's a little trickier, but it's really similar. But how long, let's look at what it says first. How long does it take for graphs of sine and cosine to repeat? From before, we should say it took 2 pi or 360 degrees. How long does it take for a graph of tangent to repeat? Well, here's 0, and then here's 0 again. Remember, each of these is pi over 2, or 90. So we get back to the same thing again at 180, which makes sense because it goes positive, negative around the unit circle for tangent. So tangent actually repeats every 180 degrees, or pi radians. Now the nice thing about that is that we only have to find the calculator answer and then add 180 degrees to it. So, what is the notation for finding the general values of the angle? It's basically arc tangent of y is equal to theta, or tan inverse of y is equal to theta. And the form for the general value for this is arctan equals theta. I probably should put a y there. Theta plus pi k only, because it only takes pi to repeat it. And finally, or tan inverse of, no, I shouldn't do that. Sorry, erase that on your paper. Or it can be theta plus 180k. And again, this is the radian one, and this is the degree one. So, in summary, when you do these problems, you use your calculator. For cosine and sine, you'll find two spots on the unit circle where that works, and then add either the 360 degree k or the 2 pi k. For tangent, you just use your calculator, get the one spot where it happens, and then add 180 degrees, because the 180 degrees will take care of the other spot. It's symmetrical for tangent, so it actually makes the problem a lot easier. Alright, so those are the notes for that. We're going to do a couple problems together, and then I want you guys to try yours for homework, and we will go over them in class. So tangent, like I was just talking about. Let's do this one first. So let's get our calculator back out, and we do second tangent of negative 5.6921. And I hit enter, and I get negative 80 degrees. But I have to turn that into degrees, minutes, seconds, because it says to the nearest minute. So I get negative 80 degrees and 2 minutes. So my theta is negative 80 degrees, 2 minutes. And I just want to show you real quick what that means for tangent. That's like right down here. Okay? Where's the other place where tangent is negative? It's over here. The same reference angle on that other quadrant. But notice how it's a perfect 180 from here, and then a perfect 180 back. So we don't actually have to calculate another angle, because the 180 will take care of itself as we go around. So our final answer is actually negative 80 degrees, 2 minutes, plus 180 degrees k. And that's it. We don't need a second angle, because the second angle is taken care of when you keep adding 180. So for tangent, you only get one solution with all the general solutions. Cosine and sine, though, we do not. So we have to do those together. So cosine, second cosine of negative 0.7521. I get enter, and I hit second angle 4, and I get 138 degrees and 46 minutes. It does not round up. So my first theta is 138 degrees. I forgot what I said after that. 46 minutes. Okay, and we know that cosine wraps around every 2 pi, or 360 degrees k. That's one solution, so I'm going to just box that right now. Now let's use a circle to find the other spot where that happens. 138 degrees is about here. You don't have to be exact about it. So this is 138. 46. The key here is x is negative. The other spot where x is negative is still in this quadrant, but the same angle here, the same reference here. So the key to this problem is we first need to find this reference angle right here. We need to find this reference. How do we do that? Well, a half circle is 180. So we do 180 minus this 138, 46 minutes, and my reference becomes 41 degrees, 14 minutes. So that means this is 41 degrees, 14 minutes, which means the other spot where cosine is negative has the same reference of 41 degrees, 14 minutes. So now I need to find the full angle of where this ends up. And hopefully you guys see, to do that, you just take 180 plus the 41.14, or 41 degrees 14 minutes. So if I do 180 plus 41 degrees 14, I get an angle of 221 degrees 14 minutes. Why is this happening? My calculator's slowing down on me. Plus a 360 degree K. So that's the other solution with multiple solutions. Okay, that goes around. Now, let's do the last one together too. And then I want you guys to try these, and we're going to go over them in class. So the last one is, we have sine inverse of negative 0.7224. Enter. We find it in degrees, minutes, seconds. Enter. So one of my answers is negative 46 degrees 15 minutes. It's okay to have a negative angle for the first one. So just use whatever the calculator gives you. And since we're in degrees, it's plus 360K. Now we need to find the other spot for that. So I draw my circle. Negative 46 is about here. Sine is negative. The other place sine is negative. So I'm going to make this a positive just because it's a reference. So this is 46.15. The other place sine is negative. Sine is y. That's over here. So we're here. The other place where it's negative is on the third quadrant with the same reference of 46 degrees 15 minutes. So what you're going to do now is you have to find out what that full angle is starting at 0. So we always measure the second angle from here. And how do we do that? Hopefully you see that it's 180 degrees plus this reference angle that we found. So the second answer for this problem is theta is equal to 226 degrees 15 minutes plus the 360K. So all the problems that you're going to try on your own now, I want you guys to go through it, just attempt. If you can't figure out the second angle, you should at least be able to type these into your calculator and get the first ones. And we're going to go over these in class, okay, because the video is already kind of long because there's a lot to it. So, like I said, I know that's a lot, but really this is the stuff you're going to be doing on the test or quiz, so just make sure you get through that and try these few on your own. Alright, and then we'll continue the note sheet on in class. I will see you guys later.